Okay. That's nice. Mm. All right, we're still on learning OpenCV. All right, cool. See how this goes. Badly, probably. All right, whatever. All right, I think we're good here. Okay, so we combine all of the descriptors by k-means. I'm guessing that's the chat. Chat rate. That one, I don't know what is. We had chat rate, but no. Alright. So sklan k-means class. K-means overview. Meaning the data points. As an example of exclusive or hard clustering method. This form of grouping stipulates that a data point can exist in just one cluster. Compression can. Partitions a data set into smaller groups based on the distance between their centroids. The centroid of cluster center is either the mean or median of all the points within a cluster, depending on the characteristics of the cluster. To minimize the sum of distances between data points. By clustering data points into clusters by using a mathematical distance measure from the cluster center, the objective is to minimize the sum of distances between data points of their assigned cluster. The nearest to a centroid a higher k value or number of clusters signifies smaller clusters with greater results in larger clusters. Next to includes iterative process based on the assigns each data point to its closest centroid. Computes the mean of all points for each cluster and reassigns it's simply yet sensitive to initial conditions and outliers. It is important to optimize the centroid initialization and the number of clusters k to achieve most important to optimize the centroid initialization. Centroid and there are several ways to evaluate and optimize clustering for the purpose of the algorithm using valuation metrics. Okay, that's fine. Quality clusters contain at least two properties of all data points within a cluster. By minimizing the intracluster distance and maximizing the intracluster distance. It's the summer. Any clustering algorithm aids minimize inertia. An evaluation metric that measures how well a data set has been clustered based on distance metrics between a data, squaring the distance and summing those two squares for each point in the cluster. Represents the relationship between clusters with high Done index. Wow, now all of a sudden. Ah, that's interesting. Kitty has stopped. Force quit. Ah, let's try. Let's try with that. I'm running a custom branch of Kitty. And it doesn't seem to be liking it. Let's exit out here. Let's see if that makes life a bit better. The done index, the second property version. Alright, so let's then. This one. Okay. Rejects. When we do the clustering, all descriptors, so fit the clustering to that. And we get that index from names in Python. Sorry, get one. You have to compute it manually after running the k-means. Okay. The done index. Okay, maybe we can just do this calculation. K-means, clusters. Might not be too bad. Done index. So print. And so the done index is the min intra divided by the max intra. Yeah, that looks rightish. Represents the relationship between the minimum intercluster distance and the maximum. clusters with a high intercluster distance. Clusters with a high intercluster distance. Are as different from each other as possible. I don't think this is a very good sentence. There are several ways to measure the robustness of a clustering algorithm. 3 commonly used metrics are the done index, the dataset D with n elements, of a centroid. A cluster is considered compact if there is a small variance between the members of the cluster. This can be calculated using this formula. And D is the Euclidean distance defined as that. Fine. The clusters are far apart. A higher done index will indicate compact, well-separated clusters, while a lower done index. First, we'll create a compact and well-separated data. Okay, so they're plotting. Okay, so there's 3 clusters and then 2 features. Number of samples, 1,000. Okay, so this is just a mechanism for generating. But this can be graphed because the number of features is 2. So because I'm dealing with vectors that are much bigger, Like, I'm not going to be able to plot those. It's good. Possibly. Good plot. Oh, would I have two windows? Is it completely good plot? Oh, okay. Oh, things what's going when I have more than two features. You cannot, yeah, you cannot directly plot high dimensional data more than two or three features on a standard 2D plot. Sure. You need some form of dimensionality or reduction to project your data down to. Principal component analysis. What is that? Mm, reduces the number of dimensions in large data sets to principal components that retain most of the original information. It does this by transforming potentially correlated variables into smaller sets of variables called principal components. It's very effective for visualizing and exploring high dimensional data sets of data. with many features, as it can easily identify trends, patterns, or outliers. PCA is commonly used for data pre-processing for use with machine learning algorithms. This is exactly what I want. Can extract the most informative features from large data sets while preserving the most relevant information from the initial data set. This reduces model complexity, as the addition of each new feature negatively impacts model performance, which also is commonly referred to as the curse of dimensionality. By projecting a high-dimensional dataset into a smaller feature space, PCA also minimizes or altogether eliminates common issues. Okay. Is a dimension reduction technique. In contrast, linear discriminant analysis. Reduce the number of dimensions and variables in a dataset while minimizing subset. PCA versus K-means clustering. Oh, okay. Base. Okay, but how to... Okay, but... Would I use PCA? Would I use PCA to reduce dimensionality. Then use K means clustering. I can visualize. Okay, but when I use PCA to reduce dimensionality of data, and then use K means so I can visualize data. So centroids in a 2D space. You have two different options and they produce different results. PCA first thing. Pros. Visualize clusters and centroids directly in 2D, simple and intuitive. Elements the clusters. Make it not reflective. Because you ran K means some information is lost in the dimensionality. Do K means first and then PC. Clustering reflects the 2D plot is just a projection, so clusters, even if they're at separate high dimensions. Yes. We combine run K means on the full data, reduce the data to 2D, transform the cluster centroids using the same PCA, plot the points with cluster colors. Yeah, okay. I think this is what I want to do. I'd really like to see what this looks like. Yeah, this is definitely what I want to do. I don't know how valuable this is going to be. It's just nice. It's just nice to see it in a graph, I guess. I think I need more stuff like Jupyter Notebook. So this is using fit predict. So how many? Okay, so if I go, what was that? Um, how many? So I don't think it takes that long to. Ooh, just probably want to start breaking this up a little bit. Yeah, maybe we can have like a class called like training data. Um, I just lost my. I probably should be using this. Okay, whatever. Python file names snake case. Let's talk to AI and Haiku. Yes, Python recommended. It's to use snake case. Okay. All right. So like, if we create training data.py, and then we make it class training data. And then we say descriptors. Okay. Descriptors. And then we do all of this. I need two more. All right. Okay. So descriptors. Let's just pass classes in for now. Okay, self first. Okay, self classes. Yeah. All the rest. dir. Like this would be used anywhere else. I don't know. It is. It's used in other places. Let's just. We're gonna really. Need scissors here to start with, because that's what we do with scissors. All right. So CV2. And the detector is. Oh, I guess we're using SIFT. Yeah. Yeah, I'm not too worried about. I gotta set up. Can I just do that really quickly? Yeah. Yeah, I feel like I wanna do this really quickly. Like set up something and then uh, you know, it's probably which key. No. And then Lua plugins, which key? The next. The next. The next. Okay, so I just go like add, that's it, and then the next. Description, move the next tab, and then how do I do library shift, and then the which key Lua, then and then SK. So I'm guessing it'll be S tab. Oh, it's already nice. Lua plugins, which key? So I think this is like S tab. S tab. The wait, the previous. Yeah. The area. I knew it made me spell P-R-E-V-I-O-U-S. V-I-O-U-S. Previous tab into next tab. Cool. Now what does that work? Because yes, I know why it's doing this. No. Convey Lua config Lua plugins. Okay. It's just lazy, just hassles you until you update everything always. Which isn't might not be the worst thing to do in the world. I don't know. Nevermore. Alright, cool. So alright, so helps if you spell it right. P-R-E-V-I-O-U-S. Okay, I think that's good. Cool. Alright. And then training now. Yeah, nice. Number hires MP. I think I'm gonna take out like format on save. That's just really annoying. Yeah.